All right, let's look at number 3. And again, I'll start with 3a. So when I'm working a problem that has a fraction, my first step is to try to eliminate that fraction. So I'm going to do that by timesing by that denominator 7, and I'll do that to both sides of the equation. So on this side, the 7's will cancel, and I'm left with 5m. And on the other side, I have 52 times 7. That's 364. Now I still want to solve for m, and I want to get rid of that 5. Since that stands for 5 times m, we'll solve for it by dividing by 5 on both sides. Subtracting 5 does not work. They're not like terms. So m is equal to 72.8. And I'm going to skip the check. It should be fairly easy for you to prove that that's true, because I want to go on to problem 3b. Whoops. We'll get rid of that. So 3b is 5k, all divided by p equals r. And we want to isolate the k. Again, my first step, since there's a fraction, is to try and eliminate the fraction. The denominator is p, so I'm going to multiply both sides by p. Then these p's will cancel. And I'll be left with 5k and r times p. R times p can be written a little simpler by just writing it as rp. And I still want to isolate k, so I'd like to eliminate the 5. Since it's 5 times k, I'm going to divide by 5. Whatever we do to one side, we'll do to the other side. Here the 5's will cancel. And k is equal to rp divided by 5. Notice how the steps for 3a and 3b were really quite similar. Multiplying through by the denominator, and then dividing by the coefficient. Multiplying through by this denominator, and then dividing by the coefficient. All right, let's do a check. When we check this problem, we want to pick numbers for r and p, all the letters that are on this side of the equation. So I'm going to let r equal 3 and p equal 4. Remember not to pick 0, 1, or 2. Several students are trying to use a 2, and you will lose points on that. So r times p divided by 5. And I will group the numerator when I do that on the calculator. So k is equal to 2.4. If this were something where I was given 2 points for the check, you've earned 1 point to get this far. To get both of the points, you have to go back to the original and put all of these values in. So 5 times k divided by P should equal R. And again, I'm going to group this to calculate it all in one step. And I'm hoping that's a 3. Great. Since 3 equals 3, I know that this answer is correct. All right, I want to take a look at B, so I'm going to clear all of this out. Because B has something in it that you may not have seen before when we're working with letters and formulas. Actually, number 4, I think I said that was B. So number 4, these are called subscripts. Exponents are up high, subscripts are down below. So this is T sub 1 plus T sub 2 equals 52. Often when we put letters in a formula, we want them to represent some real quantity like time. If you have a formula that has 2 different values for time, and you want to call both of those variables t, you might subscript them so that you know this is the first time variable and this is the second time variable. It's sort of like when you have 2 players on a soccer team and they're both called Terry. You might call them Terry A and Terry B to keep them straight, or Terry and use their last names. So think of this subscript as kind of like a last name. It does not affect the value of the letter, so it's not like an exponent. This doesn't mean t squared. So we are supposed to isolate which one? T sub 2. So if I want to isolate T sub 2, I'd like to get rid of T sub 1. Since T sub 1 is added on, we can get rid of it by subtracting. So we're going to subtract T sub 1. To keep this straight for you, I'm going to do this in color. So I'll subtract T sub 1 from this side of the equation. And I'll subtract T sub 1 from the other side of the equation. And so on this side, T sub 1 minus T sub 1 goes to 0, and we're left with T sub 2. And there's nothing we can do to combine this side, so it's just 52 minus T sub 1. Since T sub 2 is isolated, I have my solution. All right, so let's check the solution. So I need to pick a value for this variable, for T sub 1. So I'll call T sub 1 5. T sub 2 then is equal to 52 minus 5. And I'm sure some of you can do that in your head. That should be 47. This is the first step of the check. The second step is to actually see if it works in the beginning. So T sub 1 is 5 plus T sub 2 is 47. Does that in fact give me 52? Again, some of you might be able to do this in your head, but if I do it over here, I'll be certain. Great, 52 equals 52. So you have one more activity to work through, and that will be activity number 5 on page 217.